Hey, shh, shh. Everyone needs to be silent for this to work. Shh. Not sort of silent. Silent like 2 o'clock in the morning silent. Nah, more like 2 o'clock in the morning on a secluded island silent. No. That's not silent. I guess what I mean is like outer space silent. Yes. Be outer space silent and this will work.
8 times 7 is 56. He's right, 7 times 8 really is 56.
That's right, Mdea. Good job. Good job, second graders. I'm really impressed.
That's lit, Zeus.
Yep, 7 times 8 is 56. I know that, and I'm only in second grade. I'm in kindergarten, and I know that.
Okay, you guys. Thanks for your help. But these 8th graders need to learn some complex math. Times tables are just memorization. Zeus, M, G, Addie, you will all memorize them all well before the end of 3rd grade, so you will be good at division. I need to teach my class how to rationalize a denominator, if it has a term with a radical sign in it. Now, that might sound complicated, but they all have enough experience with fractions to be able to do it and to do it well. Just watch how fast they can learn the skill. All right, so the first thing we need to understand is why the square root of a number times the square root of the same number just equals that number. If we understand that, this game of rationalizing denominators is not going to be hard for anybody in the class. Okay, so why does that work? What is the square root of 4? It's 2. What is the square root of 4? It's 2. And 2 times 2 equals 4. This is going to work every single time. Let's try 9. Square root of 9 times the square root of 9. I say it equals 9. The proof, the square root of 9 is 3. The square root of 9 is 3, and 3 times 3 equals 9. So, every time we take the square root of a number, maybe 121 times the square root of 121, you're just going to get that number. Why? 11 times 11, use your calculator if you don't believe me, equals 121. So, it's going to be very, very logical how we can rationalize a denominator, and I'll get to that in the next piece of the video. Why, if I have a square root of a number, all I have to do to get rid of that radical sign is multiply it by the square root of that number again, and I will get just that number. It works with any number, even if the square root of 11,526 times the square root of 11,526. I don't have to do anything with the calculator. I just know, and I hope you do now too, that it just equals that number. Thank you. All right, so let's talk about why we need to do this now. Let's look at a fraction like 1/2 plus 1/3. When we were in 5th grade or so, we started learning about fractions and how adding them together, we'd have to get a common denominator. So we would use 6 in this case, because that's the least common multiple of 2 and 3. I multiply that by 2, so I multiply that by 2, and I get 2 over 6. Multiply that by 3, and that by 3, and I get 3 over 6. And it becomes really easy to add those together. Well, let me ask you something. Excuse those hairs all over the place. Let's say we had a fraction like 1 over the square root of 5. And I had to add it to 1 over the square root of 3. Does that look very easy to anybody out there? No, it really doesn't. I don't know what denominator I'm going to use because it's just not as easy as it was back in 5th and 6th grade. Now it's got these radical signs in it. So I say, and I think everybody in the math world says, get rid of those radical signs in the denominator so that it says something like And I'll show you how this works in a second. Now getting a common denominator is going to be easier. I'm going to use 15. But here it was really hard to decide what I would use for a common denominator. But now that I don't have radical signs in there, I'll just multiply this by 3 over 3. And I'll multiply this by 5 over 5. And I'll get 15 on the bottom. And it's real easy to get that common denominator, where it was really hard at first. That's why we're doing this. I hope that makes sense before I show you the next part. Okay, so now it's time to show you some examples of what I'm going to ask you guys to be able to do. And if you hear some birds or some little kids in the background, that's just because I'm out in my backyard doing this. Don't let it bother you. Alright, let's say you're going to see a problem, an easy little thing like 2 over the square root of 3. Your job is simply going to be just to rationalize the denominator. I'm not going to have you add any fractions or subtract fractions just yet. This will be the first thing we learn, is just to rationalize that. So like I showed you in the first video, the way to get rid of that radical sign would be just to multiply by the square root of 3. But we would have to do that on the top and the bottom, because that is 1. And you can always multiply a fraction by 1 so that its value doesn't change. This gives me the square root of 3 times the square root of 3 on the bottom, which is just 3. And then on the top, I have to just call this 2 radical 3, because I don't know what the square root of 3 is. And that's really all you're going to have to do. Okay, I'll show you another example. 7 over the square root of 15. To rationalize that denominator and get a whole number answer in the denominator, I will just multiply by the same thing, so I get that 15 on the bottom with no radical sign. Of course, I have to multiply the top by the same thing every time. Those numbers, I don't know that value, so I'm just going to call it 7 radical 15. Don't want a bunch of decimals or anything like that right now. I just want it to look just like that. Okay? There will be a little bit tougher problem that might look something like maybe 2 times radical 5 over the square root of 7. Okay, so now what happens when you see that is, same thing, you'll multiply by the square root of 7 on the bottom and the square root of 7 on the top. And when you see 2 radical signs like that, just multiply those 2 numbers together. That's going to be square root of 35. So this is going to be the square root of 35. That 2 is still out there. And again, the radical sign will disappear in there, and I've rationalized the denominator. Gigi, does that make sense? Say yes.
Yes.
Of course it does. Okay, so I'm going to try one more that looks something like this. Maybe we'll have 5 radical 8 over radical 10. Again, we'll pick this number right here. Just do radical 10 over radical 10, which is 1. And this will be 5 times the square root of 80. Just multiply those 2 numbers together. And we're going to leave it like that for now. There might be more to do later, but right now I just want to see you guys rationalizing the denominator just like that. Just like that. Do me a big favor. When you get done and you're going to turn it in, don't spill water all over it. Okay? Thank you. Okay. Reopen your flip chart in Google Classroom and go to the page that says I am my own hero. I believe it's the page after the essential question. How do I multiply a fraction with a radical in the denominator by 1 and make the radical vanish? Try those while I limp around and watch. Thanks.